Hi folks, welcome back to part 2 of lesson 1 where we're going to be covering the principles of chemistry. So in the last part we got to specification point 1.6 and specification point 1.7 is an experiment where it's a practical where it tells you to investigate the solubility of a solid in water at a specific temperature. And unfortunately, we can't do that now, so we're going to have to skip to 1.8, which is the next specification point. We need to understand how to classify a substance as an element, compound, or mixture. So we need to know that an element is a substance made from only one type of atom. A compound is a substance made from two or more elements that have reacted chemically with each other. A mixture consists of two or more elements or compounds not chemically combined together, and the chemical properties of each substance in the mixture are unchanged. Now, we need to know, sorry about that. Now, we need to know we need to understand that our pure substance has a fixed boiling point, but that a mixture may melt or boil over a range of temperatures. So a pure substance, basically a single element or compound not mixed with any other substance, or that's nothing add to it. So it is unadulterated and in its natural state. For example, pure milk or pure water. Pure substances melt and boil at specific temperatures. This melting and boiling point can be used to distinguish pure substances from mixtures. So these melt and boil at specific temperatures, and the data can be used to distinguish pure substance from mixture, because if it's a mixture, it contains two or more elements or compounds. And if it melts over a range of temperature, it means that they are a mixture. So moving on to 1.10, we need to describe these experimental techniques for the separation of mixtures. Simple distillation, fractional distillation, filtration, crystallization, and paper chromatography. So let's start with simple distillation. Simple distillation is used to separate a pure liquid from a mixture of liquid. So to separate a liquid that hasn't been added anything to it from a mixture of liquid which has two or more elements or compounds in it. So this works when the liquids have different boiling points, and it is commonly used to separate ethanol from water. So taking the example, ethanol has a lower boiling point than water, so it evaporates first. The ethanol vapor is then cooled and condensed inside the condenser using condensation, the method, which goes from a gas to a solid, to form a pure liquid. Sorry, no, gas to liquid. Apologies. A sequence of events in distillation is as follows. Please note this down. It goes from heating to evaporating to cooling to condensing and to condensing. So 4 steps: heating, evaporating, cooling, and condensing. So now let's move on to fractional distillation. In fractional distillation, the oil is heated in the fractionating column, and the oil evaporates and condenses at a number of different temperatures. This is very covered in alkanes, which we're going to be covering in topic 4, organic chemistry. The many hydrocarbons in crude oil can be separated into fractions, each of which contains a molecule with a similar number of carbon atoms. The fractioning column works continuously. Heated crude oil is piped at the bottom. The vaporized oil rises up the column, and the various fractions are constantly tapped off at the different levels where they condense. The fractions can be processed to produce fuels and feedstock for the petrochemical industry. So next, let's move on to filtration. So filtration is a very useful process, because if you've produced, for example, precipitate, which is an insoluble salt, and it doesn't dissolve in water, you will want to separate the salt from the salt solution. You would do this by filtering the solution and leaving behind the precipitate, which is the insoluble part. In crystallization, finally, if you were to have produced a soluble salt and you wanted to separate the salt from the solution that was dissolved in, you will first warm the solution in an open container, allowing the solvent to evaporate, leaving a saturated solution where no more solid is dissolving. Then allow the solution to cool, and the solid will come out of the solution, and crystals will start to grow. These can be then collected and allowed to dry. So now let's move on to chromatography. So chromatography is used to separate mixtures and give information to help identify substances. It involves a stationary phase and a mobile phase, and separation depends on the distribution of substances between the phases. So the more soluble substances, the further up the paper travels. Analytical technique separating compounds by their relative speeds in the solvent as expressed in the paper, and separates different pigments in a color structure. So this is 1.11. We have to understand how a chromatogram provides information about the composition of the mixture. RF value. No, that's 1.12. But for 1.11, we need to know that it can be identified using RF values, the number of components in a mixture, and these components. So this separates mixture into individual components. So compounds in a mixture may separate into different spots depending on the solvent, but a pure compound will produce a single spot in all solvents. So the RF value, how do you calculate it? You calculate it by dividing the distance moved by substance by distance moved by solvent. Different compounds have different RF values in different solvents, which can be used to help identify the compounds. Finally, it's a practical, but unfortunately, we're not going to be able to do it. We have to investigate paper chromatography using inks and food colorings. That should quite easily to be done at school. Well, this brings us to an end of part 2 of lesson 1. I hope you really enjoyed this. Thank you.